I don't think of myself as only a physicist. It's so wrapped up in what I am. It's not a career. It's just who I am.
I think asking as many questions as you possibly can is like the best thing that I've done in my career.
I'm going to show you how you can separate iron from cereal using a magnet.
WFSU Public Media's STEM adventures are brought to you by Atkins and FSU's National High Magnetic Field Laboratory.
Oh, it's blue!
Woohoo! Since 2006, WFSU Public Media and the National High Magnetic Field Laboratory at Florida State University have held summer camps for young women interested in science, technology, engineering, and math, also known as STEM. Based on the national PBS program called SciGirl, these hands-on experiences at a variety of locations around our community have encouraged many middle and high school girls to consider and pursue careers in STEM fields. Over the years, the camps expanded, adding more girls and more adventures. But this year, COVID-19 changed the plans for 2020. Now, instead of heading into the field to learn and experiment, we're bringing STEM adventures to you.
SciGirl rocks!
The MagLab is a very special place. Scientists travel from all over the world to do experiments here. They come because they are curious about how things work, what they look like inside, what makes them tick. They are full of questions. Questions the MagLab can help answer because we have some of the biggest, strongest magnets in the whole world. Some of them even hold world records. Our magnets aren't like the magnets that stick to your fridge. Scientists love our magnets because they let them see things they couldn't otherwise see. They are a different type of magnet that engineers design and build here. Magnets that use electricity to create very strong magnetic fields, way stronger than those little kitchen magnets. Scientists who are curious about something put that thing, they call it a sample, inside of the magnet, then watch what happens. Being curious creatures, scientists often do different things to their sample while it's in the magnet. Sometimes they make it really, really cold. Sometimes they pressurize it. Sometimes they run electricity through it. They might even shoot a laser at it. With every new thing they try, the scientists measure how the sample changes. The sample gets quite a workout. So does the scientist. But even in the face of hunger, exhaustion, and homesickness, the scientist perseveres. Maybe her research, like other magnet research before hers, will lead to more efficient electrical wires. Maybe it will help cure diseases like cancer or Alzheimer's. Maybe it will result in better, faster computers and cell phones. All because she had the courage and the curiosity to ask a question.
We are so excited today to have Dr. Laura Greene from the National High Magnetic Field Laboratory. Welcome, Dr. Greene.
Thank you, Roxanne. I'm very happy to be here.
Great. So could you just introduce yourself to us?
Okay, well, my name is Laura Greene, and I'm the chief scientist at the MagLab, as you said, and I'm a Kraft professor of physics at Florida State. I'm also involved in a lot of international projects for science diplomacy and human rights, and involved in things like the International Union of Pure and Applied Physicists and a bunch of other things. So besides science, I do a lot of other work.
Can you tell us how you describe your job to the general public?
There's so many facets, it's difficult. So usually I consider who I'm talking to. So one aspect of my job is really being in charge of the science drivers of the MagLab renewal, which is taking up about 60 hours a week right now. And it's really fun because the Magnet Lab is so broad in what it does. And from biological work to geology, chemistry, physics, and also the work that you do in the education and outreach was really one of the main attractions for me coming to the Magnet Lab. But also my own research is on quantum materials. And I like to think, I give a general talk called The Dark Energy of Quantum Materials because there's so many fundamental unsolved problems, and we're constantly trying new techniques to understand these materials. And, most of what I'm talking to you on this computer, most of these materials are pretty new, and they really change everything, our economy and the way we communicate. So also a lot of what I do is worry about bringing physics to developing countries and working within countries where there might be two different academies where they don't necessarily get along because one's political and one's more scientific. And so I do a lot of that, and also work on human rights for scientists. So.
That's great. That's actually a great summary, Laura, for all that you do. When did you first become interested in physics? When did you first become interested in physics?
I have a standard answer for that. I was hardwired that way. So I have a birthday tomorrow, and I don't think I'm going to tell you I could tell you how old I am, but anybody that's my age, all my girlfriends, we were never encouraged to do science. And I remember being so small that I had to reach up to the bathroom sink, wondering why water was soft as opposed to the sink being hard. So I just always had this, and looking at the stars and things like that, I was totally addicted to it. It was like a calling. So
did you ever have a setback in your career? And if so, how did you overcome it?
Oh, never. Absolutely not. No, never had a setback. Oh man, there's so many, from the point of girls shouldn't be doing this. When my parents found out that between 5th and 6th grade, I was in a science class, a summer science class, and I was the only girl, they got really mad at me. So I was discouraged a lot. I think one of my biggest setbacks that I really came through on was when my thesis advisor just sat down with me and said, "You are not going to get a job in physics. I will make sure that you don't. You're just not good enough." And so I can go into reasons why that happened, but I remember how I overcame that. And I ended up just deciding I'm just going to do the best interviews I can, and I got a job at Bell Labs. So I think I've had many of these things where I thought, I can't do this, I'm going to give up, it's going to kill me, What I do is I think back to a place where I did overcome. I remind myself, and I play that tape again, and I remind myself how I looked in the mirror and I kind of proverbially sharpened my teeth and walked into the interview with my head held high. So,
what advice do you have for middle school and high school girls who are interested in STEM?
Well, try to think back on what you really love about it. So my analogy to that is that there's a reason for people to get married, I decided. Because after a certain amount of years, when someone puts the fork in the wrong spot and you blow up at them, you remember there was a rite of passage there, okay? And you try to remember that. And so for me, I try to remember some of the great joys I had in figuring something out, or even if it's not figuring it out, just learning something new, learning that, what is this about curved space? Wow. And the other thing is, since women are minorities in STEM, it's so important to have your girlfriends. I do this all the time. And so when you feel any minority, it's true, not just women or any minority in any field, when you feel like you're the only one that feels that way, it's very important to say, am I crazy? Yeah, you may be crazy, but listen. And then the analogy I have is that, you give someone over the email or something or whatever, a proverbial hug, and then you push them back out there and say, you can do this. And I find that that's very helpful. And it's also helpful to talk about with your friends as much physics as you can, or science, but also other things. And because it's, I don't think of myself as only a physicist. It's so wrapped up in what I am. It's not a career. It's just who I am. So it all gets wrapped up together.
That's beautiful. So the next question is, how has COVID-19 affected your job?
Well, I guess it's so funny because it's had dramatic effects and zero effects at the same time. I actually don't do much lab work anymore. I've got people in my lab that are turning the knobs, and it's actually counterproductive. I mean, I miss it. You get successful, and all of a sudden you're not allowed in your lab anymore. But it's just inefficient. But last year I travel a lot, and last year I put on 700,000 flown air miles. That's not bonus miles, that's air miles. So I did most of my work on airplanes. I bought the International Go-Go, which reminds me, I should turn that off now. And I did my work on airplanes and hotel rooms and in the last round meetings. And now I'm just doing it at home. So in some sense, I kind of miss the acceleration of the airplane, but in some sense it's it hasn't really changed. I'm still writing reports. I still have tons of meetings. And the other thing, I had so many video meetings. When I was president of the American Physical Society, I probably had 6 or 8 a week. And so I'm quite comfortable on these video meetings. I don't feel, I feel like I'm right there. So, it's interesting. I will say that what I found, and most of my friends that are academics or researchers, or in any kind of field, that we all feel like we're working 16-hour days or longer with about 3 hours of output. And so that's the other thing, is that all the OCD and ADHD just really kicks in, and things are coming in, you're working on something, and then you get less efficient. And so that's the other thing, is that they're long days.
Well, thank you, Laura. Those are all of my questions. Is there anything you want to say or any closing comments that you want to make?
Oh, I can't think of anything except that try to stay positive. You're not always going to be positive in this global pandemic. You're going to have a panic attack here and there. The other thing, I used to work randomly, sleep randomly, etc. I find that I'm at my desk at 8:30 in the morning, sometimes earlier. I try not to. And I try to end the day by 6 or 7, and then do some other things, get some exercise or watch TV or something, or just something different. And so I find structure really helps me. And the other thing is that if anybody wants to be in touch with me, you know how to find me. So I'd be happy to talk with anybody.
All right. Well, thank you so much, Laura. It was so great to talk to you today.
Nice talking with you too. And thank you very much for doing all this.
Magnets come in all shapes and sizes. They can be made in different ways and used for different things. This sticks stuff to your fridge. This makes breakfast. And this helps scientists discover new things about materials and about physics itself by revealing subatomic phenomena. You might not think of a toaster as a magnet, but anywhere you have a moving charge, you have a magnet, even in a toaster. That's because moving electrons create a magnetic field. You can prove this yourself by making your own electromagnet. Electrons actually move from negative to positive, but since the convention is to think of electricity as going from positive to negative, that's how we've shown it here. To make your magnet stronger, increase the number of loops in the coil. It's a simple equation. The more current, the stronger the magnetic field it creates. But there's a lot more you can do with electromagnets than just pick up paper clips. Powerful research magnets give scientists a way to peer inside everything from petroleum to semiconductors to the brain, and to see what's going on at the atomic level. At the MagLab, we take the idea of a simple electromagnet and scale it way up. Instead of copper wires, we use copper and silver discs and stack them in a coil. We also build magnets from a special material called a superconductor, but that's a story for another time. Then we pump lots of electricity through it, about 29,000 times more than your toaster uses. That translates into 41 Teslas, which is how we measure magnetic fields. Now let's put something inside the magnet and do an experiment. Here's a material called graphene, which is basically a one-atom thick layer of carbon that has some really interesting properties. Physicists want to know more about how it behaves, to find out if it could be useful for building faster computers or other applications. To get it inside the magnet, they attach it to a long stick, called a probe. Scientists measure all kinds of things using magnets. In this experiment, they are watching what happens to electricity in graphene when it's in a strong magnetic field, and when it's very cold. For example, when they lowered the temperature, the electrons encountered less resistance. When they turned on the magnet, the field exerted a force on the electrons that affected their path. Two of the phenomena they observed, called magnetoresistance and the Hall effect, help physicists understand graphene's properties. Signals about what happened in the sample travel back to the scientists, who analyze the data and figure out what it means. Then they share their discovery with scientists everywhere, helping to build knowledge about our remarkable world. Not bad for an amped-up toaster.
Hi, my name is Sandhya, and I'm going to show you how you can find iron in food. Iron is one of the most common elements in Earth's crust, but it also plays a really important role in our bodies and is found in a lot of foods, including spinach, beans, and some enriched cereals. Iron is a major component of a protein called hemoglobin, which is predominantly found in our red blood cells, which are the oxygen-carrying cells of our body. Oxygen binds to the hemoglobin protein and is transported all over our body. Since iron is magnetic, I'm going to show you how you can separate iron from cereal using a magnet. To do this project, you will need cereal. Total cereal or Gerber Area cookies work the best because they're rich in iron. You will also need a Ziploc bag, a strong magnet, one made out of neodymium will work the best, a clear plastic cup or bowl, and some water. The first step in this is to take about 1 cup of cereal and place it in a Ziploc bag. You then want to close the Ziploc bag and make sure there's as little air as possible. The next step is to mash your cereal up as fine as possible. This will help it dissolve faster. I'm using a mashed potatoes masher. After it's mashed, it should look something like this. You can also use a blender to get it really fine. The next step is to add water. You want to add about 1.5 cups of water until the bag is half full. Then you want to close it. After making sure your bag is sealed, you want to let it sit for at least an hour. This will allow all the cereal to dissolve. After 1 hour, your mixture should look something like this. The next step is to pour some of this mixture into a clear bowl or glass. Once your mixture is in the cup, you can take your magnet on the side and stir your mixture gently. You also want to move the magnet around. Soon you'll see a little black dot accumulating. That is your iron, and you'll see that when you move your magnet, the iron ore will follow. This is a really cool experiment to see that most of the iron your body requires comes from your diet. Men require about 10 milligrams of iron a day, and women require about 15 milligrams of iron a day. People whose diet does not have enough iron can become anemic, a disease in which your body does not produce enough hemoglobin, and it is characterized by fatigue and weakness. So remember, eat your iron-rich foods and cereals and stay healthy. Hi, I'm Sandhya Kumar, and I'm talking to former SciGirl Lucy Toman, who is an industrial engineer. So Lucy, tell me a little bit about what a day looks like for you as an industrial engineer.
Ooh, good question. So as an industrial engineer, I work at an engineering consulting firm. So that means that all of our clients, we kind of work on different projects. We aren't assigned to one specific client. So we kind of see a client's project throughout its entire life cycle, which I really like because it makes every day a little bit different. Usually there's I'm in a lot of meetings during the day, but a lot of it is just design work. So trying to work with the other people on the team, the project teams at Burns & McDonnell, which is the company that I work for, working with them to ensure that the design that we're creating for our clients is what the clients want, and also that it'll work with what we're trying to build or trying to construct or trying to improve upon. So it's a lot of meetings, it's a lot of collaborating with people that maybe have different degrees than I do or different backgrounds or expertise. Kind of every day is a little bit different, but it's all kind of working towards this goal of making sure that our clients get what they want in the end, whatever that may be, whatever that project may be.
That's pretty cool. I think collaboration is definitely really important in science. What project are you currently working on?
So I'm working on a project. We're building a factory, and we're working on it. So we're doing it. It's a factory that we're building from the ground up. So it's something that we call a greenfield project, which means literally where we're going to place the factory only has grass on it. So not only do you have to build the process inside to make the product, it's a consumer good, so something that you could buy off the shelves, but to make the product, so you build the process inside, but the building around it, you have to build in the lights that go in overhead, you have to build offices for all of the workers to be in at the actual plant. So it's a really cool project because we get to kind of see it from start to finish, from like concept on a piece of paper to actually buying equipment, which is what I'm working on right now. Like specifically, we're buying the equipment that goes inside the building, and then maybe in about a year or so, we'll hopefully be able to see it actually get built from the ground up and have everything like be completely finished and product running through the line.
What got you interested in engineering and specifically industrial engineering?
That's a good question. So I think that's like a very hard thing. Like as you're going through high school or even middle school, if you're like a real go-getter, like I bet a lot of people watching this are, you kind of are trying to answer that question of like, what do I want to be when I grow up? And honestly, I don't even know if I figured it out yet, but what I'm doing so far is like, okay. So I knew that I liked math and science. I knew that from a young age, I had like a very great second grade teacher, and she was awesome at teaching math and teaching science, and had x-rays on the walls, and cut our principal's tie to teach us fractions, which I thought was like the coolest thing possible. So she kind of really inspired me to like math and science from a young age. And so I kind of took that, and I knew that I wanted to do something along the lines of math and science in college or after I graduated, but I didn't quite know what. But I also knew that I really wanted to wear, and still to this day, wanted to wear heels and a dress to work. Like that was one of things. I hate pants. I don't know why. It's just like a weird Lucy thing, but I just wanted to be able to wear a dress. And so me being able to find a career that maybe I could marry those two things in was something that I was trying. Maybe it was on the list of things to find. And so I kind of started Googling what different types of engineering there were, and kind of what the different paths that you could go down. And honestly, I wish I had like a better story, but I like found a Wikipedia article about industrial engineering, and I read it, and I was like, that kind of sounds like me. Like I like the idea of optimization and efficiency, which are kind of like our IE's buzzwords, and kind of that's how my brain works. Of like, you go into the grocery store and you pick which line to go down based off of like how many people are in it and how fast the cashier is checking people out, and kind of how quickly people are putting things on the conveyor belts. And so like that made sense to me, and so I thought, let's give it a try. And I went to UF, and UF happened to have an industrial engineering program, and so I kind of started out on it.
So as a SciGirl, what was one of your favorite camp experiences?
So I think I have two that I remember like very distinctly. One of them being the marine biology lab, where you go and I think either spend the night or go for a super long day and do some marine biology work with the FSU extension. And I thought that one was super cool because you got to be in the water and you got to kind of see what life was like outside of just like humans or on land, which was super cool. I think also being a swimmer, I kind of have like that a little bit of affinity for extra water whenever possible. So that one was a really cool one. And then the other one that I remember was it was kind of a model of a forensic scientist, what someone in like a forensics lab would do. And so there were bones that were buried in the back of the MagLab, and we excavated them and then brought them back into a conference room and had to analyze them based off of their size and whether or not it was a male or a female. And that I thought was, I'm a big like crime show watcher, and so I think that like I was doing what Abby does on NCIS was like very cool. So those were probably the two that I remember the most.
Yeah, I also really love those experiences. I love the marine biology lab because we live in Florida and getting to explore our natural surroundings is really great. And the forensics thing is really cool because, like you said, you see it in crime shows and you never really get the experience to do that.
Exactly, yeah.
So what advice do you have for girls who are wanting to pursue a career in STEM?
Ooh, okay. So I think my advice, or like a one piece of advice that I give is the question thing. So I think a lot of times, like, and maybe people say this, maybe this is one that's said before, but I think asking as many questions as you possibly can is like the best thing that I've done in my career, and not only just like my work career, but in my college career, my high school career. I think that sometimes, especially being women in maybe a field that's dominated by men, there's a sense that maybe you shouldn't ask questions, or that there's judgment or something if you do ask a question in a room full of men. But I think that for me, that's been like the biggest thing that I think has advanced or just enhanced maybe my career, because guarantee it, if you're in a room and you ask a question, somebody else is thinking the same question and they're just not as confident as you are to ask it. So I think that would be my one thing, is that asking as many questions, and don't let anybody tell you that questions are silly or stupid or anything like that. Like, I mean, it's any type of question, any question is a good question. So continue to be curious and to learn about the world as you move through.
That's really great advice. I definitely will implement that in my daily life. Well, thank you so much for talking to me today. It's been a pleasure talking to you.
Yes, thank you so much for having me. It's super fun.
Thank you.
WFSU Public Media's STEM adventures are brought to you by Atkins and FSU's National High Magnetic Field Laboratory.